In this video, we will demonstrate the 3-point gain transfer module, which utilizes the 3-antenna method for solving the Friis equation. This method measures 3 antennas and compares them to one another over every possible combination. Antenna A is first measured with antenna B. Then antenna A is measured with antenna C. Finally, antenna B and C are measured. This leaves us with 3 equations with 3 unknowns. While the antenna measurements can be made in a general manner, they must be physically compatible. In this example, we are going to measure 3 horns. 2 of them are from the same manufacturer, while the third is from an entirely different manufacturer. To begin with, the measurements are done by setting the DAMS positioner settings to measure but without moving. After we set the positioner settings, we leave the extents unchanged, assuming we haven't changed the actual positioner. We configure the extents for only 3 points. We'll go from 0 to 360 in steps of 180 degrees. At this point, we would perform the measurements on the 3 antennas. Once this is done, we would save each measurement sequentially to Reg 1, 2, and 3. These measurements have already been performed, so we're going to recall the data. This is the measurement of horn 1 against horn 2. This is horn 1 and horn 3, and finally horn 2 and horn 3. Now we must generate the path loss. The measurement distance for all 3 horns was 1 meter. As you can see, the path loss button has turned green. Now we can invoke the 3-point gain transfer module. As the window explains, we must make sure that we have the proper data in the proper registers. Once we calculate the associated gains, it will replace the data in the registers, so we want to be sure that we've saved this data before we've utilized the 3-point calculation. In this case, we now have the linear gain of horn A, horn B, and horn C, each stored in Reg 1, 2, and 3. The best way to visualize this data is through the polar plot module. Please see our polar plotting video for step-by-step instructions on that particular module. Another way to view these results is through the simulator monitoring plot located in the antenna network simulator. This will also give us the amplitude response and the phase. After opening it, we first scale the plot from 0 to 20 and utilize the hold button in order to compare all 3 horns. We'll first recall horn C and the data is displayed. We'll then recall the same data from horn B and we can see they agree very closely. Lastly, we'll recall the data from horn A. This is the horn from the different manufacturer. We can see it's close but has a slightly different profiling characteristic. The 3-point method has an advantage of not requiring a reference antenna. The only disadvantage is that it requires knowing the path loss amounts. And this concludes our overview of the 3-point method. We hope this video has been helpful and informative. Thanks for watching.